Welcome to another exciting adventure of Mr. Wernell Does Your Homework. Alright, so today we're going to be taking a look at some velocity type of questions. And these aren't too bad to do, so let's go ahead and get started. Question number 1. They give us the position of a particle at time t is greater than 0. It's the velocity, so we typically think time can't be negative, so t is greater than 0 is normal. They'll most likely always give that to you. Next, then they give us the position of the particle. Now, the first thing I notice is that these are parametric equations. And we're typically parametric with velocity questions because it's parametrics, as we said in an earlier video, will give us change in position, and will give us our position and the change in that position or direction. So we typically leave in terms of t, for example, like time. So the first question says, find the magnitude of the velocity vector. Alright, so let's kind of review here real quickly. Well, what is the magnitude of the velocity vector? Well, in an earlier video, we said that this is equal to speed. And we have a special symbol for that, like these double absolute value symbols. So that is how we get this. So there's a formula for this, and if we think about it, to get the magnitude of the velocity vector, we have to find out, well, what is our velocity in the horizontal? We get our velocity in the vertical. And this distance right here between them, this is that speed, or the magnitude of the velocity. And how we get that is just using the Pythagorean theorem. It's just x prime of t squared plus y prime of t squared. So we're going to need their derivatives. So I'm going to go ahead and find out my velocity equation. We get the square root of. The derivative of x is 2t, so that becomes 2t. We're going to square that, plus y. Well, the derivative of y is just going to be 2t squared, so that becomes 2t squared. And we want to find the velocity here at t equals 2. So now we're going to let t equal 2, and then we can get our magnitude of velocity, or the speed, plugging this in. 2 times 2 is 4. 4 squared is 16. Plus 2 squared is 4 times 8 is 16. Whoops, sorry, that's terrible. 2 times 2 is 4 times 2 is 8 squared. That is 64. Don't tell anybody I messed up on my arithmetic there. And that's just the square root of 80. We don't need to simplify that, but if you want to, that is just 4 root 5. So that is the actual speed of the particle. So, in other words, horizontally the particle is traveling at 16 units. Vertically the particle is traveling at 64 units. And the actual speed is 80 units, root 80 units. Alright, now for part B says, set up an integral expression to find the total distance traveled by the particle. So to get total distance, we talked about this in another video. Distance is equal to speed times our time. Now we're talking about minute amounts of times, so we're going to call that dt, the shortest amount of time possible. Well, speed, that's our magnitude equation. So that is our square root of x prime of t squared plus y prime of t, I'll get rid of this here, squared. Now that is a very incremental, tiny bit of our distance. So remember, we have a particle. The particle could be looking like this, right? So we're only talking about little tiny bits of the particle. But there's infinitely many of them, and we're just going to add them all together. And to do that, we use integrals from a to b. So this is how we get distance. Again, if you need to see more, I do have an earlier video on that. Please take a look at that. So what we're going to do is we want to find this distance traveled between 0 and 4. So we would integrate this 0 to 4, the square root of x prime of t squared. So that is this 2t squared plus 2t squared squared dt. Don't forget your dt. And they don't ask us to solve it, so we can leave this alone. That's okay to do. We're just going to leave that alone then. They don't ask us to solve it, don't solve it. All right, the next question says, for part C, it says, find dy dx as a function of x. Well, okay, so I can look at this, dy. There are two ways I can do this. The easy way, just to use the derivative, this I know is y prime of t over x prime of t. And if I go over here, let's see here, if I plug this in, what is y prime of t? We know y prime of t is from earlier is 2t squared. X prime of t is just 2t, and that just, of course, is t. Well, what is t equal to? Well, I want this as a function of x, so I want y to be a function of x right here. So if I go up here to my equation, there's my x right there. So I know that x is equal to t squared minus 2, so I can just solve for t. T is equal to the square root of x plus 2 here. And there we have it. All right, part D, we're mathematicians, we love the part D. All right, part D is now asking, at what time is the particle on the y-axis? Now, this is a tricky question right here. If we want to be on the y-axis, we know that x is 0. The definition of the y-intercept is x equals 0. Then we want to find the acceleration, which we know at this time. So we would need x double prime of t and y double prime of t at that point. Use your chevrons. So let's see here. Let y be 0, right? So let x be 0. So we want to find out first where x prime of t is 0. Now we already have x prime of t already. That's just 2t. So that's sorry about that. That's x prime. I totally messed this up. Sorry, remember the definition is when x is 0, not x prime of t. Sorry about that. So this should be when x of t is 0. There we go. And I can do that from up here. We know x of t is t squared minus 2. So I put this t squared minus 2 equals 0, and we get t is root 2. Remember, there are two possible answers, positive or negative, but they told us at the beginning that t has to be greater than 0. So now we just have to find the acceleration of this. So we know that the velocity, we know that is just 2t squared. To get acceleration, I just take this derivative again, and we get 2 and 4t. Remember, we're going to use our chevrons here. It's a nice way to look at them. That's they're called chevrons. It's a way to say this is a vector. So a of root 2 will just be 2 and 4 root 2 right there. And there we have it. All right, I hope you enjoyed this example right here. Go on to my next video and we'll do another one. See you soon. Bye.